Hi folks, I've had a couple good questions come in from students about the ideas and kind of the concepts around velocity and acceleration. So I'm going to go through some of the things that have been asked and make some kind of supplementary videos here, and hopefully it will help you to understand a little bit better. So I've got a summary here of some different situations with velocity and acceleration and what that actually means. So the first one, if the velocity is 0 and the acceleration is positive. So what that means, velocity equals 0. This means it's stationary or at rest. So there's no movement. But the acceleration being positive means that the velocity is increasing. So the velocity is increasing, but at that moment, the velocity is 0. So what that might look like in a table, and obviously in a table, we're kind of only looking at average rate of change, but you can still hopefully sort of make the connection to this instantaneous rates of change from the derivative here. So if we had time and velocity, so whatever scale we've got doesn't matter here. If, say for instance, the velocity was -6, -3, 0, 3, 6. So what this shows is at this point here, at time equals 3, the velocity is 0. But the acceleration, remember, is the rate of change of velocity. So here we're going up by 3, up by 3, up by 3, up by 3. So this acceleration is the rate of change of velocity. And normally we're talking about obviously the derivative being the instantaneous rate of change, but hopefully kind of connecting it to that average rate of change or the first differences in a table of values can help you see that. So in terms of the numbers, this is what's happening. There was a negative velocity. It has come to a velocity of 0, so it's at rest, and then the velocity is becoming positive. So that's what this positive acceleration means. Kind of looking at what was happening in the situation. If you kind of imagine, again, kind of this, my eraser being the particle is moving quickly in a negative direction. So probably, assuming it had some kind of constant acceleration, was moving in a negative direction. It slowed down and stopped, and then began to move in a positive direction. So at that slowed down and stopped, at that instant where it was at rest, its velocity was 0, but its acceleration was positive because the velocity was increasing through the 0. So the velocity values were at the 0 point, but it was increasing past that. So this means at rest, but velocity is increasing. So this means that the velocity is currently 0, but increasing. That most commonly happens in a switch between a negative velocity and a positive velocity. Movement in the negative direction and movement in the positive direction, but not always, especially for a displacement or position function that's not a polynomial function. You could get something where it was moving in the positive direction, stopping, and then moving positive again. So in that situation, you might have a velocity of 0, but an acceleration that's still positive because it will be increasing. In a polynomial function, it would almost always be a regular turning point just because of kind of the shapes of those graphs. So this Next one, velocity equals 0, acceleration is negative. Again, that's very, very similar, but kind of the opposite situation. So this is stationary. And the negative acceleration means velocity is decreasing. So we could imagine that in a table again of time and velocity. And the velocity here will be decreasing, but passing through a 0. So maybe the velocity is 3, then 2, then 1, then 0, then -1. So in this case, we've got the velocity is decreasing by 1 each time. That -1, -1, that shows that we have a negative acceleration. At this point here, the velocity is 0, but the acceleration is negative because it's decreasing. So this situation might be the opposite. You're looking at something that's moving in a positive direction, coming to rest, because the positive velocity has been decreasing, decreasing, slowing down, stop. That's the instant we're talking about here. And then it begins to move in a negative direction. So the velocity goes from positive to negative. Typically for a polynomial function, that's what's happening. So this would be at rest, but velocity is decreasing. Okay. Velocity is greater than 0, so that means moving in a positive direction, whether that's to the right or up. I'm just kind of using left, right here. And acceleration is equal to 0. That means it's a constant speed. Constant velocity, I shouldn't say speed, it means different things. So the velocity is not changing. So what that would look like in a table might be a constant velocity. So it's not changing. The acceleration is the change in velocity, and it's not changing. So constant, positive velocity. And I'm going to say speed just to kind of give you a real life picture. Speed not changing. Even though it's velocity, not speed. That's a bit kind of colloquial. The next one is the opposite of that. V at t is negative. So this is moving there. So like left or down. And again, acceleration equaling 0 means constant velocity. So what that might look like in a table, if we looked at the velocity over different times, it's just going to be the same negative value. It's not changing. So the change in velocity is 0. So that would be a constant negative velocity. Again, the speed's not changing. It's going in the negative, the left or downward direction. And it's not changing. Okay. The last one is kind of an interesting case. We've got the velocity is 0. Whenever we see velocity is 0, it's stationary. And acceleration as 0, that means the velocity is not changing. So this is kind of a boring table. If we looked at time and velocity, it would just be staying still. So this is a different kind of velocity equals 0 than what we saw up in the first two examples. Here the velocity was 0 or 0 here, but just for an instant. So there was just a split second, an actual instant where the velocity was 0 in between movement. So here it was moving in, sorry, in this one first one, it was moving in a negative direction. Then it stopped just for an instant before it started moving in the positive direction. Down here, if the acceleration is 0, the object's not moving, but it's not just not moving as it kind of moved and then changed directions. It's just not moving and staying still. So around that time t, whatever t you're given where that's true, the object is at rest and it's not changing.